So the oxidation numbers we're going to do today, and again, you're going to need the... Okay. We come up here and find it and swap it. You probably are going to need the steps because I want to go through these and make sure that you know. Again, it's not hard. It's just the math is going to change just a grunt. All right, so here's the first one we're going to do. Now, you're going to see real quick how this is different from the ones we've done before. Right off the bat, what's the one thing that you already notice is different? There's a charge. Very good. So I'm going to go through the exact same steps we've always done. So step number 1, determine if the compound is neutral or charged. You've already established that it is charged. But here's what we have not done. If it were neutral, what did you set it equal to? 0. But this time, you're going to set it equal to. And it says, if it is charged, set it equal to the value on the charge of the ion. So I'm going to set this equal to -2. Everything from here on out is the same. The only thing that's going to change slightly is the math. Guys, make sure you're writing this down. It means your phones do not need to be a part of this. Okay? Same rules as follows. So the next one is anything by itself? Nope. Keep on moving. Number 3, do you see parentheses? Nope. Keep moving. Number 4, do you see a metal? Nope. Keep moving. Number 5, fluorine. 6, oxygen. Yes. Okay, so in this case, oxygen, just like always, is what? -2. Bring that math down, so I've got -8. Now this again is where your brain has to think a little bit. Just like with the last one we did, is if you treat this just like it's algebra, so much easier than anything you're probably doing in any math class. So don't mess this up. If I've got 8 negatives and I need to keep 2 of them, what do I need? 6. Very good. Super simple. So +6, what am I having to divide by? Nothing. So that is my answer, +6. Do you agree that nothing has changed except the math is a little different? Okay. Looking at the next one. NH4 positive. For those of you that don't remember how to do this, what is the name of that thing? Ammonium. Very good. Now, first question, neutral or charged? What do I set it equal to? +1. Again, I implore you, I'm begging you, put the signs. It's not that much more difficult. All right, so again, second rule, just like always, is anything by itself. Number 3, do you see parentheses? Number 4, do you see a metal? No. Number 5, fluorine. 6, oxygen. 7, hydrogen. Yes, let me read this just to make sure we're on the same page. It says hydrogen has an oxidation number of +1 in all compounds containing elements that are more electronegative than it. Is nitrogen more electronegative than hydrogen? Look up there. Is nitrogen closer to fluorine? Yes. All right. So hydrogen's +1. I know I got to solve for nitrogen. So +1 times 4 is +4. Now again, basic math. I've got 4 positives. I only need 1. -3. Fantastic. And then what am I dividing by? 1. So the answer is +3. Do you agree? My bad. My apologies. I messed that up. That is -3. Thank you for correcting me. What worksheet? I didn't give you. I just gave you those. Yes, ma'am. Rule. Without a rule. Because if you notice, nitrogen's not on your list of rules. So basically it's the, and on the test, I'm going to go ahead and tell you the way it's going to be. It'll say, let me rewrite this. The way this will look is I'm going to have it just like this. It'll be NH4 positive, and then one of them will be bold and underlined. And so your answer will be whatever the oxidation number for that one is. So like on the previous one, this would have been bolded and underlined. So you would have given me +6 as your correct answer. This one? Sure. No. Because like on the test, you'll just write in +6. Yep. But you'll show me your work, and then on the answer sheet, you'll write +6. You good? All right. Go ahead. All right, say that one more time. You got it? All right, so you guys try this one on your own. See what you come up with. Actually, try both of these. Now, let me go ahead and forewarn you of something. Step number 4, ask if it's an ionic compound. Let me ask you something. Cr2O72, that is a polyatomic what? Ion. Is this a compound? Remember, compounds don't have charges, right? So the answer to that question has to be no. So don't treat chromium like a metal. Treat it like it's just a regular element. All right, so first question. Neutral or charged? Charged, set it equal to -2. Now, we can go through all of our sets of rules, but we know we're going to get all the way down to step number 6, and oxygen is going to be what? -2. All right, Jamila, -2 times 7 is? -14. Now, again, this time I know that I'm not making it 0. So if I've got 14 negatives, but I only need 2, how do I cancel those out? 12 what? 12 positives. Now, is my final answer 12? What do you do? Divide by 2, so your final answer is +6. So that should have been your final answer. Everybody good on that? Okay. All right, now this one right here, I'm going to go ahead and tell you this is going to get you. First question, charged or neutral? Set it equal to -3. Well, there's only one thing there, so what does that value have to be? -3, so it is -3. So, if it's by itself and it's neutral, it's 0. If it's by itself and it's charged, it's the charge. You don't have to think about it. Yes. Yep. All right. There will be a quiz on this tomorrow. I have not thought about that. All right, try that one. If you can get these two, we should be ready to move on. Yeah, I mean, this is as difficult as it gets. Oxidation numbers don't get any harder. I tell you what, Lawrence, since you asked that question, just out of curiosity, any of y'all that did the homework, the ones that said oddballs and rule breakers, do y'all want to go over those? All right, I'll do those. Because there are some that are kind of funky. We'll look. All right, so first question, set it equal to what? -3. Again, we just know our rules that we know oxygen is -2. Bring down our math, we know this is -8. And so what do I have to make that to balance? +5. And so this is +5. And then over here, this is equal to -2. I know this is -2. I know this is -6. That makes this have to be +4. And so my final answer is +4. Okay? It's not hard. Once you learn the rules, this stuff flies. So here's what I do want to do. I want to do the weird, strange oddballs and rule breakers from the homework that you guys did over the weekend, just so you see some of the weird ones that you're going to come across. And I promise you, if you follow the rules, everything will take care of itself. So, number 19, it was BaH2. First thing, what do you set it equal to? 0. Now, this is when you have to know these in order of importance, because what's going to happen is you're going to see the hydrogen and you're going to jump on it first, but I'm not going to do that. I'm going to show you why. So if you follow the rules, number 2 says, is anything by itself? The answer to that is obviously no. Step 3, do you see parentheses? No. And here's number 4. This is why you have to read them in this order. Is this an ionic compound? Is the first element a metal? Yes. That is important, and here's the reason why. So what group is barium in? Group 2. So I'm going to go ahead and list that. Let's go all the way down to step 7, because that's the next step that matters here. Step 7 says hydrogen has an oxidation number of +1 in all compounds containing elements that are more electronegative than it. And then it says this exception. When hydrogen is with a metal. Is that true or false for this example? That is true. So this example must be followed as it goes. Has an oxidation number of -1. So if you jump on hydrogen and go ahead and throw in the +1, you're going to mess this all up. And let me show you how you can correct that if you do make that mistake. But first of all, let's finish it this way. If you did not know that rule about hydrogen, here's what you're going to do. Obviously, you'll bring down a +2. What do you have to have right there? A -2. And what is -2 divided by 1? Excuse me, -2 divided by 2. It is -1. So you can still solve for the answer. But let me show you how you would know that you messed this up if you jumped on hydrogen first. So if we did BaH2, again set it equal to 0. If you went ahead and put the +1 here, let's look and see how you should know that this is wrong if you do it this way. What is +1 times 2? So what does that mean right here? -2. And as soon as you write -2 right here, an alarm should be going off in your head. Why? Barium is in what group? It has to be a what? +2. You should catch that. The second way you can catch that, even if you didn't know barium is supposed to be a +2, can a negative ever be written first? No, you've never written a negative first. So that should be your second indicator that something is wrong with this. And so again, if you follow the rules, that's why I put this under the oddball and rule breaker, because it is a little bit different than the ones we've always seen. Now, number 20. I'm going to be honest, I hate these compounds more than anything. Na2O2. No, I'm not going to give you one like this. Yes, ma'am. Okay. Cations must always be written first. Cations? You know what a cation is? It's a positive ion. Okay. Let me rephrase that then. Cations must be written first in all compounds. That NH4 positive is an ion, and so it doesn't follow the rules. I know, and it's weird. It's one of those strange things. Let me rewrite this to make this make a little more sense. Because that's technically what it is. What polyatomic is that? Peroxide. So here's what would happen. If I gave you this example, and I asked you to reverse crisscross, what are you probably going to do with that 2? You're probably going to pull it up. But if you did that, is that right or wrong? That's wrong. Because why? Sodium's in what group? Group 1. Now, if you do it in this version, what do you know about those parentheses in that 2? They're protecting. You can't do anything. So what's technically back here? A 1. Now that looks right. This is why I hate peroxide, because it makes everything look kind of funky. You just got to know it well enough to catch it. So let's redo it and actually do it the right way. So Na2O2, and if you follow the rules, set it equal to 0. Nothing's by itself. This is an ionic compound, so what's sodium have to be? How do I know it's a +1? It's group 1. What is +1 times 2? +2. So what do I have to have right there? -2. But what is -2 divided by 2? Now, find rule 7, or find rule 6. In rule 6, do you agree there are 2 exceptions? The first bullet says in peroxides, such as hydrogen peroxide, oxygen's oxidation number is -1. Is that exactly what we just got? Yes, I will not intentionally, on purpose, give you a peroxide. If I do, make me not make it count. Okay, I don't like these. They're very confusing. 20. All right, so the next one. NH4 2CO3. Just throwing this at you as a group. Can you name that? Don't say it out loud, but can you name that? You should already have the names memorized. You shouldn't even have to think. Massimo, what is it? Where's the Cl? Yes, sir. Ammonium carbonate. All right. Follow the rules as always. Neutral or charged? Neutral. Anything by itself? Step 3. This is the important one. Do you see parentheses? What do you do with those things? Distribute. Okay, so here's what you got to do. N2H what? 8 CO3. And I'm still going to set it equal to 0. And there are actually several rules involved with this one. This is actually probably one that has the most rules involved. Number 4, is it an ionic compound? Nope, don't have to worry about it. Step 5, I don't have fluorine, but step 6, do I have oxygen? Yes, and so what is oxygen going to be in this case? All right, -2. Step number 7, hydrogen has an oxidation number of +1. That is still true because there are no metals present. And then we've got step number 8, and this is why I came back in and added this step. Are there 2 or more elements left without an oxidation number? Yes. What do you do? The one that's more electronegative gets the charge from its group number. So of nitrogen and carbon, who's more electronegative? Nitrogen. And what group is nitrogen in? 15, so what's his charge? Very good, -3. Now it's just basic math. -3 times 2 is -6, +1 times 8, +8, -2 times 3 is... All right, so now you got to do a little bit of thinking. How many total negatives do I have? 12 total negatives. How many total positives do I have? 8. Well, I got to get them equal, so what do I have to add? Very good. 4 what? 4 positives. Am I going to have to divide by anything? Nope, so +4 is my final answer. Does that make sense? Okay. All right, number 22. NH4 AlSiO4. This is one ugly compound. Okay, but if you follow the rules, it'll all make sense. What am I setting it equal to? 0. Nothing's by itself. I see no parentheses. Do you see a metal? Who is it? And what group is aluminum in? 13. So what's its charge? All right, so I've got 3+. All right, I don't have fluorine, but do I have oxygen? Yes, so what's oxygen? -2. I have hydrogen, so what's hydrogen? +1. And then I've got 2 left. Go ahead. All right, I agree with that statement. However, do you agree that NH4 is present? It's a part of that polyatomic thing. And this is why I don't give these to you. This is why these are oddballs and rule breakers. They're very funky. But again, if you can kind of see through that, it does help. Of the 2, nitrogen or silicon is more electronegative? Nitrogen. So nitrogen gets my -3, and so I got to solve for silicon. All right, so I've got -3, +4, +3, and -8. How many total negatives do I have? 11. How many total positives do I have? So what do I need? Sorry, I looked at you funny. That kind of threw me off. +4. So that should be your final answer. Number 23 is a good one as well, so let's look at it. OF2. First and foremost, we know it's 0. If you follow your rules, this actual problem is on the rule sheet itself. Because it says, and we're going to go ahead and skip all the way down to step number 5. What's the second word in step 5? Always. Fluorine is always a -1. But let's look at number 6 where it says oxygen. Oxygen usually has oxidation number -2, but read the second bullet under the exceptions. It says in compounds with who? Such as OF2. This is the exact problem we're working on. Oxygen's oxidation number is +2. I could have completely left that off and you still could have sulfur. That. Here's why. Because you just read that fluorine is always what? -1. Well, what is -1 times 2? -2. What do I have to have there? +2. +2 divided by 1 is? So there's your answer. So the math still works. The math still works. All right, let's look. We got two more. CAS. CAS. Set it equal to what? 0. Now what do? I don't have a hydrogen, oxygen, or fluorine. Very good. Ca is a metal. And what group is Ca in? 2. So it's a 2 plus right here. Bring this down. 2 plus. What do I have to have? 2 negative. And there's your final answer. Okay. So don't freak out if you don't see a hydrogen, oxygen, or fluorine. There's got to be something else in there that has a rule. Here's the last one. NH4 2PO4. Now, what's the one thing that jumps out to you on this one? Parentheses. Let's go ahead and take care of those first. You know, I probably should have put parentheses first before, like, make that rule number 1, because you're going to have to do that anyways. So, NH2H8. Yes, ma'am. No, ma'am. Leave them separate. Because they are and here's why. Is the H on the outside has nothing to do with the H on the inside. Because the way, like if you were to draw the structure of it, that H is attached to a different location in the bond, so you can't make it a part of the H4s. All right? Now, we know oxygen's -2. We know hydrogen's +1. And yes, you can have them in 2 different locations, but then we come down to 2 that don't have a rule. What rule number do we actually have to account for this? 8. This is the last one. If 2 or more don't have an oxidation number, the one that's the most electronegative gets the charge from the group number. So who is it, nitrogen or phosphorus? Nitrogen. Seems to be always the case. So we've got -3 here, and we've got to solve for P. So I've got +1, not +6, -6, +8, -8. Now, you guys are smart. What do the positive -8 do? They cancel out. Don't even pay attention to them. Does that make sense? Now, nitrogen is higher up. Yes, ma'am. All right, that's a good question. So how did I know that number right there? What group number is nitrogen in? 15. 15, okay? So group 15 is charge is -3. Always. Unless it's with something more electronegative than it. There is an example. Let me find one. I think there's one. Let's pretend that there were 2 left, and one of them was nitrogen and one of them was chlorine. All right. Do you agree? Let me actually back all this up. No, I'm glad you're asking this, because this is important to understand. So do you agree that there are 2 elements left without a number on top? So if you read rule number 8, I've got to figure out what one of those numbers are, because if I don't know one of them, I can't solve it at all. And so rule 8 says, are there 2 or more elements left without an oxidation number? The answer to that is yes. So the rule says the more electronegative of the 2, so either nitrogen or phosphorus, gets the charge from its group number. Now, it just so happens to be that phosphorus and nitrogen are both in group 15. But because nitrogen is higher up, it's more electronegative. Okay? And so that's why we assign nitrogen the -3 here, so we can bring this down. So that's got to make that number a little different. You with me? All right. Do you agree that those 2 numbers essentially cancel out? All right. So here, I've got a difference of +5. So that makes phosphorus +5 and not -3. And the reason why is because it's less electronegative. So if you and I were to get in a fight, if you're more electronegative, you're going to take my electrons from me. So since nitrogen is more electronegative, it takes from phosphorus. I'm breathing hard. It'll turn your insides inside out. Sour candy, it might kill you. Alright, so again, in Schoology, this is the title, Determining Molar Mass, Formula Mass, and Percent by Mass. There's only one part that you've got to have memorized, and you already know it. I've just got to pull that back to the frontal lobe. So we're going to work on this part right here. And once, I'm not going to tell you what we've done. I'm just going to see if you're like, oh yeah, I remember doing that. So here's step number 1. List the elements that are present. Okay? Who are the elements present in letter A? All right, so do it just like this. So we've got iron, nitrogen, and oxygen. This is not drawing. We're not drawing these things. The second thing you need to do is list how many of each are present. How many irons are there? Why are there not 3 irons? Do you distribute outside? Very good. Only distribute into the parentheses. A 3. Can you see what it is? This is the formula we're working on. That's the formula we're working with. Okay? So, say it again. Because you only distribute to inside the parentheses. Okay? How many nitrogens are there? There are 3. And very careful how many oxygens. I knew. Now you know why I say things. So, do you agree that's really easy? The next part just uses your eyeballs. What you're going to do is you're going to multiply each element by its mass. You just got to look it up. Now, real quick, do you remember how many decimal places we rounded to? 2. Now, if you look up iron, it is 55.85 in your brain. No, you look it up on the periodic table. Which, again, you will have this. I'm not going to take it away from you. I just don't feel like passing them all out, because by the time you got them, we'd have to pass them all back in. Say it again. Paper version? No. It's either in Schoology or on your own paper. Oh. All right. Does anybody happen to remember the mass of nitrogen? It's 14.01. Now, some of you should remember oxygen. What was oxygen? 16, very good. Now, I do need somebody's help. So I encourage you from here on out, if you guys have calculators, you leave them in your lockers or something, you do need to bring them every day from here on out, because everything is going to be calculator. Okay? Now, here's what I need you to do. I need you to multiply all these numbers. Very good. That's the simple one. So I've got 55.85. What's the next one? All right, so I've got 42.03. And then what is 16 times 9? 144 point what? Duh, 00. That was stupid. Now, so here's my question. The whole entire objective is to find the total mass of this compound. How many of you remember doing this? Okay. Now, here's the problem. Here's why you have to go through all of these steps. Is there one box on the periodic table with that formula in it? So this is what you have to do to figure it out. Now, how do you get the total mass based on all those numbers? Add them up. So, what's the final total mass? Do what? All right, 241.88. Now, this is the part that I told you a minute ago that you have to memorize, but guess what? You already know it. I just got to pull it back to the front. Does anyone remember the unit on molar mass? Per? Very good. Grams per mole. You've heard that before. I know you've heard it before. You just got to rememorize it. Yeah, just write it down. On all molar masses are gram per mole. That's it. All right. Now, that's the first part. The next part is the baby step that I said I was going to add that's just as easy. So we just did molar mass. Next is percent by mass. And here's the type of problem that would ask you. Of the entire compound, let's just hypothetically pick nitrogen. What percent of that entire compound is made up of nitrogen? And it's really easy. Let me kind of come off of this and let me give you the real world example of this. First of all, what is that symbol? Percent. What is a simple, very basic definition of a percent? Very good. Now, here's the problem. If you did this mathematically, would that give you the correct final answer? No. What do you have to do to all percents? Multiply times 100. So here, let me give you real life. What if I wanted to know the percent of females that were made up of this classroom? How would I do it? Perfect. Brett, say that one more time. That's exactly right. So what we're going to do is we're just going to talk about compounds. You can tell me percentages. So if I counted all the girls, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, no, excuse me. I forgot y'all took me in the back, my bad. So 12 divided by the total number, whatever that would be, and that would give you percent. I could then do boys. I could do any type of percentage you wanted me to do, and it's never going to be more complicated than part over whole. So let's look at the chemistry aspect of it. 2 iron, 3 nitrate. How many parts are there? 3 parts. What's the whole value? 241.88. So here's what I want you to do. Do this right here. So I'm going to take each part and divide it by the whole. And that's going to tell me the percentage of every single one of these. Does that make sense? That's all you got to do. Part divided by whole. What if there were only 2 parts? You would do it twice. What if there were 4 parts? You do it 4 times. Okay? So that's all you got to do. So someone do 55.85 divided by 241.88. Tell me what you get. Actually, let me show you this. I want to do this one with you guys real quick. And there's a reason why. So 55.85 divided by 241.88. Now, do you have to every single time multiply by 100? What can you really do? Move the decimal how many places? Twice. Which way? The right. Don't make it a smaller number, make it a bigger number. So if you move that decimal 2 places to the right, what percentage would you get? 22%. Okay, now let's do the next one. Oh, wow, that was really bad, my bad. 23%. All right, so the next one, we come over here, is 42.03 divided by 241.88. And I'm going to go ahead and do the next one. 144 divided by 241.88. So I already have both of them. So what is the percentage for nitrogen? 17%. And then what is the percentage for the last one? Why 60? Got to round up. Now, here's the last step, and this is only to double check your answer. All percentages should add up to be what? 100. Let me give you some good news for the day. If you do this and it adds up to 99, leave it alone. That's perfectly acceptable. If you add it up and it's 101, leave it alone. That's acceptable. So I'm giving you a plus or minus 1 on both sides because of rounding. Because here's why. I heard some of you, what if you would have left that at 59? What would your percentage have been? 99. That's just a rounding error. Leave it alone. But if you get 98 or 102, fix it. You get 99, 100, or 101, you're good. So is this easy? There's really nothing hard about it other than getting your unit right and making sure you put the right mass down.